share this. Okay, so that was the formal homework on Unit 2, which is relationship. So the first question we had was, we had a diagram which was showing a parabola. So you had equation y equal kx squared. Now the first thing you'd ask is, find what is the value of k. Okay, so usually when I do get a parabola like this, I look at it, and maybe it's something you could think about is, you see this parabola, it's going through the point 0, 0. That makes sense, because what you need to look into is, if you get x equals 0, what is the value of y? You can see that 0 times anything will be 0. So that's why it's going through that. And that's the type of parabola that we get. So in order to solve this, what do? You need to do to pick a point. Obviously, you can't pick 0, 0, because you're still not going to get k. So you want to pick a point that will enable you to get k quite easily. So the easiest point, I would say, when you get here, is to pick a point. Imagine if x equal 1. 1 square is still 1. 1 times k is just k. So that means if we pick this point here, I'm going to call it point 1 for x, and it's got a 4 for y. If we pick this point, you just now substitute the value of x equal 1 and y equal 4. So y equal 4, k times 1 square. So 1 square is just 1. I put positive 1, but it's the same thing as 1. So because 1 square is 1, 1k equal 4. So the common mistake, or one mistake I noticed, was someone wrote something in the line of 4 equal k1 and went, okay, then maybe k is 1 over 4. I can see why that person did that. I think you could think of, if I move k on the other side, then that means I need to divide by 4 here, blah, blah, blah. So to me, putting something like that because you thought of something is okay. But then you can always find out, did I get this okay? So to do that, the first thing you do is, if you put k equal a quarter, do back again. If y equal 4, k is a quarter. Is that correct? Is 4 equal a quarter? No, that's not correct. So maybe somewhere I've made a mistake. And this is where you need to use what you've been given to quickly check your work, and you'll be able to find out that that's not correct. The k equal a quarter doesn't work if you just try the point again. That might be helping you to spot a silly mistake. So 1 mark, not much in it. You can see there was not much math involved into it. Okay, but apart from that, yeah, all of you guys got this one okay. Don't think it was a difficult one. So if you got any question, guys, remember, you can put that in the comment. So the second question, can you see that okay? Because I had to scan my paper with my answers there. Can you see it okay?
Yeah.
Yeah, is that clear enough? It's just sometimes scan. Okay, so the second one you had was, again, equation of a quadratic function. But what they gave us this time is what we call the completed square form. Completing the square was what we've been doing whenever we had x plus a square plus b. And that usually helps us to find out our turning point.
Yeah.
So first of all, you write turning point in x. Remember, you always start with x. I've got x equal 2 and y, which is this y-axis, equal -1. Okay, so that's the bit now where people got a bit confused. decided to say, okay, if that is 2, that is -1, then that's got to be A, that's got to be B. Okay, so let's think about it. First of all, why do we do completing the square? It's to get what we call the turning point. Okay, what does that mean? It means it's the bottom, the lowest point I could get on my function if you've got, what, remember the smiley face? Oh, it's the maximum turning point if you've got a negative sign in front here. That's why we do the completing the square. And when do you think y is at its minimum? When this portion here equal 0, yeah. Because you've got something square, that something will always be positive. So to make it the smallest, what's the smallest of, if you can call 0 a positive number would be 0. So y is going to be at its lowest point in here, which is when b equal -1, b, y equal b, but when this equals 0. So this x plus a equals 0, we said when x equal 2, so you write 2 plus a equals 0. And how do you solve that? Because you've got 2 here, take away 2 both sides, and that means a equal -2. Or sometimes we just say minus a because it's the opposite of a here. So if you've got x plus a, x, when x equal minus a plus a will equal to 0. So that's why a equal -2. So the b is the value of y, but for x, you need to change the sign. So if you got 2 here, then a is -2. Okay? So I'm not sure if that is clear. So whenever you're going to see x plus a squared plus b, the turning point is going to be minus a and positive b. So
the turning point formulas is, I always try to remember this, is minus b over 2a, but that's not when you're dealing with completing a square, is that correct? You could use that possibly.
Minus b over 2a.
Yeah.
Yeah, so that's when you've got, remember when you had like ax squared plus bx plus c?
Yeah, that's the full form.
Yeah. Yeah, so that's different. Whereas whenever you're going to get completed form, you just write it like that. Okay. And that's why here, 2 marks, 1 mark for a equal -2, and the second mark for b equal -1. So now sketch the graph. So we said when we're going to sketch the graph. So here I don't have completed the square form, but I've got what we call the roots straight away. So when is y equals 0? So that's your x-intercept. This time this is 0 if this is 0 or this is 0. So that means x minus 6 equals 0, x equals 6, x plus 2 equals 0, x equals -2. So straight away, I've got my graph crosses the x-axis at 6, 0, and -2, 0. So they want us to sketch the graph, and they want us to give the coordinates of the turning point. Okay, so I've got now my two, what I called x-intercept, where it crosses x. The y-intercept is when x equals 0. So we've done that with straight line. When x equals 0, this time we're going to get 0, subtract -6 times 0 plus 2 is just -6 times a +2, which is -12. So I've got graph crosses y-axis at 0, -12. And now to find the turning point, you will look for this one. So if you want to call this x1 plus this second point, and you halve them. So that means you're going to be halfway between where it crosses the x on both sides. So 6 plus -2, that's 6 minus 2, divided by 2, is 4 divided by 2, which is 2. So the turning points happen when x equal 2. So, but when x equal 2, you need now to find the value of y. So you plug x equal 2 inside your function. 2 minus 6 is -4, times 2 plus 2, which is 4. So -4 times 4 is -16. So then you state the coordinate of the turning point. Here, you get that mark. The coordinate of the turning point is 2 for x and -16 for y. And you put them into brackets. Okay, so I've got everything I need. Now, to draw it, you just put x and y. So we said 6, 0 is one of the root, -2, 0 the other root. We said we're going to cross by 0, -12. And the turning point is 2, -16. So if someone asks me to rewrite this in completed the square form, I would say this is y equal x minus 2 square minus 16. Yeah, so I can quickly check if this is correct, because that was x plus 2 times x minus 6. Yeah, that would be x squared minus 6x, so plus 2x, that's x squared minus 4x minus 12. So completing the square for this, you have that number, the 4. Then because you've added 4, you need to take it away. Minus 4 minus 12. And that is me back to, I can quickly check that my graph has got a good chance of being correct, because this turning point is exactly what my completing the square form would look like. And that is exactly if I was to do this.
To find the turning point on the
Yeah.
graph, you can use completing the square for it. You can use the completing the
Correct.
square.
You've got more than one way. So to find the turning point, if you didn't get the roots correct, you would say, because the root I just said here, you could just draw this and say between 6 and 2, I've got 8 steps. 4 from 6 is this point here, is x equal 2. So you could have mentioned it like that if you wanted to draw the graph, or you could say this, I'm going to write it as a completing the square, and I know that this is minus a would be 2, and b would be -16. That's my turning point. So you've got 3 ways to be able to draw this. Okay. Next one we had, okay, this time a parabola has equation x minus 3 square plus 2. So look what I've done, x minus 2 here, square, and axis of symmetry is the line that cuts your parabola in half, and that is x equal to here, is what we call axis of symmetry. Yeah. So now coming to this question, I've got x minus 3, 1 mark, don't have to do much work. I know that x equals 3 is my turning, is where I'm going to see my turning point. So axis of symmetry is at x equals 3, or x minus 3 equals 0, which is x equals 3. Now the next question, write down the coordinate of the turning point. Now that I know x equals 3 is where my turning point is, I didn't even need to do all this. When x equals 3, y equal 2. State whether it's a maximum or minimum. I've got a positive number here in front of x squared, so the coefficient here is positive, so I know this is minimum. And the turning point is at x equals 3 and y equal 2. That's why it was 2 marks. One for stating minimum and one for giving the turning point. Okay. Next question, I had solved the equation. Okay, so solve the equation is the same as finding the roots. That's exactly the same thing. Remember when we were drawing our graphs, we find where we were crossing the x-axis. We cross the x-axis when y equals 0. That is exactly the same thing. It's like you've been asked to look at a parabola when y equals 0. How do you get y equals 0? What is the value of x when y equals 0? So basically that's the question. How can you get 0 here when you've got something times another thing is equal to 0? So it's either this one equals 0 or the other one equals 0. So x minus 3 equals 0 when x equals 3. So you just add 3 for both sides to balance your equation. And x plus 5 equals 0. You just take away 5 on each side when x equals negative 5. And that's probably why it's only 1 mark. Okay. Next, here I've underlined what's the most important part here. Give the roots correct to 1 decimal place. So, formula sheet, you got to use quadratic formula. Whenever you're going to be asked to find the roots correct to a certain number of decimal place, you have to use that formula. There is no other way to find it. So what did we say? We need to identify what a is. So this is like if you had ax squared plus bx plus c. So a equal 1, b equal negative 5, and c equal negative 7. You write b squared minus 4ac, which is negative 5 squared, 25, minus 4 times 1 times negative 7. So a negative times a negative is a positive. You get plus 28. 28 plus 25 is 25 plus 25 plus 3, which is 53. And now I'm just going to use negative b, which is minus 5, plus and minus root 53 divided by 2 times 1. And these are my two answers. So now we've been asked to give them correct to 1 decimal place. You plug that into your calculator. So I've seen people struggling with this. So could you do me a favor, and if you open your scientific calculator, use the fraction button. So it's the one on top left, and don't use the divide. I think I've noticed someone used the divide, and when they used the divide, they forgot to put the brackets, and that didn't give them the right answer.
After that mistake before, I just do the first bit and then divide.
So now you need to get used to, you see that divide sign? That's called an obeli. The obeli was just added in, but in reality, it's to put a number at the top and a number at the bottom. It's a fraction. So if they give it to you on your calculator, make sure you use it. You've got less chance to make a mistake if you use it than if you use that divide sign. You'd be surprised how many people put this in their calculator, 5 plus root 53, and then just put divide by 2. Do you know what happened? BODMAS, it does this first, and then it adds 5 to it. Yeah. Whereas if you put 5 plus root 53 with the brackets, divide by 2, you will get the right answer. But to avoid making that mistake where under stress during an exam, you might forget the brackets, please on your scientific calculator, use that button that is just under that option button, OPTN, whatever. Left, bang, press that, put what you've got at the top, use your arrow key to navigate and put the answer, and you've got less chance to make a mistake. Okay? It's just minimizing ways of making mistake, and that is one of them. So 6.1, it's okay, guys. Remember, we're doing these formal homework to see what do we need to do to stop making that, mistake. And this is one of them. Law of mark there. Last thing we want is just making a silly mistake of entering into a calculator. So I usually put ... Once you put three decimal point, that's fine. Remember to then round it to 1 to get your final mark. Yeah. So important, the lesson to learn here is I do my discriminant first on the side. I've seen folks sometimes trying to write everything under the root, the square root. It's so easily done, but you remember we here to try and minimize the amount of mistake we make. It's much easier to type this than typing the full thing there. Okay. Next. So again, this is another thing that should point us to what we need to use. Determine the nature. So whenever you're going to see this word, so solve, give your answer to roots, you use the quadratic formula. Determine the nature of the roots, you need to use this discriminant, b squared minus 4ac. You need to calculate that, and that will tell you if the nature of them are like real, different reals, no real roots. Okay, so identify a, b, and c, 3, 2, and 1, b squared minus 4ac, 2 squared minus 4. Oh, I get a negative number, so I know when I've got a negative discriminant, I'll get no real roots. Okay. So there you go. 1 point for calculating this. Another point for stating that this is negative. So you either write b squared is negative, is less than 0, then, or in math, you just use less than 0. That means no real roots. 1, 2, 3 marks. Okay, so if you put less than or equal, you don't get the marks, because when it's equal to 0, you will get some roots. Next question. 8, sketch the graph. So remember what I said, sine is usually the easiest to sketch because it's more natural. So when you're asked to sketch, remember guys, a sketch, but if you put in the sketch something that look like 5 units on the y-axis, do the same length of units on the x-axis when you put your negative. I've seen someone putting me here -5. To me, that looks like a -1 rather than a -5. And then try to squeeze down the bottom of its, okay? So you might say, yeah, but that's what I meant by that. But try, don't give that, whoever's gonna mark you, the chance of not giving you the full marks because of something that trivial. So make sure there is a bit of symmetry in your graph, remember? they're all symmetrical. So you've got symmetry here, you've got a half between, this is your amplitude, okay? So that was worth 2 marks. The first marks was to show that you've got your correct amplitude and that you've got as well your, what we call the roots, or where it crosses the x-axis. So it crosses at 90, crosses at 270. So I saw someone putting me here 180. Again, guys,
Yeah.
divide this by 4. So it's easily done because you think of the other one.
Yeah, I realised that.
So you just, you put on your amplitude, you know, the same step, but again, divide 360 by 4. If it's just a normal cos x, there's one signal within 360. And then you get the second mark by giving it like
it's
that.
Just remembering what points cos goes through and what sine goes through. I've actually written it up now just to remind myself. But
you see this? I say to everyone, this is your best friend in class. Do you see that? If you draw it, you're not too sure, or I put 180, type cos or 5 cos 180 and tell me what you get. So if you type 5 cos 180 on your calculator, negative, there you go.
-5.
So
-5, so you're on the right tracks.
That would have been straight away to you, oh, maybe I got this one wrong. What is it wrong?
Okay.
When do I get a 0? And then you'll find 5 cos 90 will be a 0.
Yeah.
And then
would I have got a mark, even just plotting it out with the intent of going around the right points there, or did I just got enough?
So if it's 2, the only thing, so if you've got the amplitude, you will get 1 mark. Right. If you get the amplitude, you will get the mark. If you get some of these wrong, then to get 2, you need to have those 2 and the amplitude. You'll get 1 for the amplitude, definitely. But that's the hard bit, is the person that put an amplitude of 5 there and put a wee dot here, -5. I could see some teacher not giving it. So the next one was, what is the period? Okay, so what we said about the period is, in the x-axis, what is the value that we put when the signals start to repeat itself? So if you've got 4 signals within 360, so let's say we've got 4 signals, 1, 2, 3, and 4. So I've got, this is 360. We said we've got 4 signals. My period is this. It repeats itself here. So you've got 1, 2, 3, and 4. So that's got to be 360 divided by 4, which is 90. Then that's got to be another 90, which is going to be 180 there. And then another 90. And then that's your period. Your period is when it starts repeating itself. So that is your period. So basically the period becomes just t equals 360 divided by 4. You don't need to draw all this. But the period is just 360 divided by the number in front of x here. Okay, so that's what the period is. Last question, probably the hardest, I would say, because you hadn't done a lot of work on cosine. So some of you got a few marks here and there, 1 or 2, or I didn't think a lot of you got 3 out of 3 for this. It's about to do with practice, right? So the first thing first, solving this, most of you got that okay. Cos x equal -2/3. So that'd be your first mark. So 33%, you should get that. Now, this is the bit where, how are we going to treat this? Cos is negative. That means my solutions are in this quadrant and in this quadrant. Remember here we've got 0, here we've got 90 degree. Yeah.
Mhm.
Here we get to 180. Here it's going to be 270.
Yeah.
And then you get back to 360 because you're back to the square, the circle, right? So here I would say 360 and 0. That means my answers need to be between 90 and 180 and between 180 and 270. So if you've given an answer not within that, those two, then you should ask yourself, okay, maybe I've made a mistake somewhere. So what we do with this CAST diagram or quadrant diagram, sometimes people call it, we write CAST and we know where cos is negative because it's where it's not positive. A, all the signals are positive. C is positive here. That means it's negative here and negative here. But the first thing we find is this first quadrant angle. So that's the one that we need to do. No matter what you're going to do, you have to find the V positive, the angle that is associated with the quadrant where they're all positive. And to do that, you've got to change the sign of this to start with. And I think that's where people didn't change the sign, but got the first value okay. And now we're not too sure what they do with the second one. So this question gives you an extra point because you give this as the answer, but you still don't have a full method. You need to have a foolproof method that tomorrow it's going to be a tan here for you during an exam, and you're not going to get them. You're not going to get any of these correct. Today's a cos, you managed to get a second mark, but with another signal, you might not get a mark. Okay? So once we find that angle where they're all positive, which is changing the sign of this, and I get 48.189, and I'm convinced that this is a very good answer because it's positive between 0 and 90. So now you could go and say, in the second quadrant, I've got 180, take away this angle to become between 90 and 180. And in that third quadrant, I'm going to get 180 plus the angle there that I found, and that gives you the second mark. Question was asked to solve it. No, they didn't say. So just get the habit of adding that. I've picked one decimal place and I wrote it. This is one decimal place. And whoever's going to mark me is going to say, okay, he's got that right. He's got that right. He's got that right. He's probably not even going to bother looking at everything. Remember, some of these markers, sometimes they've got to mark 500 papers and they don't have a lot of time to do it. So they go bang, bang, bang. They expect you to have got all these okay. But if they see something wrong between the two, then they start digging in and they'll go, okay. So did you see my calculator? I put that when I was doing this work, I made a mistake because I was teaching in higher and advanced higher, we don't use degrees anymore. So my calculator was set into radian, and look, I've just went, 0.841, never thought of it. And I went, that's bad. I should have checked that it's got to be in degrees. Okay.
Would you lose a mark if you don't put degrees in?
Oh, you mean the wee dot there?
Like for your final answer?
No, that's okay. You won't lose a mark because what I've done here, I've put X with a wee degrees and then put the answer with the wee degree. So if you put X without the wee degree, that's fine.
Right, okay.
No, you won't lose a mark for that. Okay. So that was the wee homework. Like I said, because this is quite fresh, you probably guys would need to revise on that more than the rest, I would say. Here, understand what a period is. If it's 4 here, divide by 4 if you want to, or draw it just to help you out. This one, nature, b squared minus 4ac. If you can't remember b squared minus 4ac, look at your formula list. It's given you the quadratic formula, and it's whatever is under the square root. Okay. This one, correct to 1 decimal place, quadratic formula. Finding the roots, that was quite straightforward. And a wee bit of parabola work. Okay, guys, so it wasn't too complicated, but at least it gives you an insight